Okay, we're going to go ahead and take a look at everything we've kind of worked on so far. This is day one's lesson. So share the screen. So all of this is predicated on reading the unit circle backwards. So, what I've done for you so far is I gave you a problem and I said, for example, let's go ahead and let's find ourselves, the sine of pi over 3. And what y'all did is you went to pi over 3. You came out here and you saw this point out here and you said, oh, well, the sine is the y part. So sine of pi over 3 is root 3 over 2. Okay, what we're going to do now is we're basically going to read it backwards. I'm going to ask you sine of what angle equals root 3 over 2. Okay, this is called inverse. And usually what ends up happening is you'll see it written one of two ways. You'll see it written like this: sine -1 over root 3 over 2. That's arc sine. And it's also actually written out as the word arc sine. Both words mean the same thing. Now, here's the deal. When we do the arc sine, we have to restrict our range. What I mean is when we take the inverse of a function, specifically with the trig functions, we actually have to restrict where we can do it. And the rules are as follows. When we're looking at our arc sine, we're going to look in quadrants 1 and quadrants 4. When we're looking at arc cosine, we're going to look in quadrants 1 and quadrants 2. When we're looking for our tangent, we're going to look in quadrants 1 and quadrants 4. When we're looking for our cotangent, we're looking in quadrants 1 or quadrants 2. Okay, and then what you're going to see is when we get to like secant and cosecant, this is also going to be where we look for our cosecant, but you're going to see how we are going to kind of convert it to answer a question. And this is where we actually look for arc secant, quadrants 1 and 4, because cosine goes with secant and cosecant goes with sine. Okay, so now here's the deal. What I'm saying is we're never going to look down here in quadrant 3. We're only going to look in quadrants 1 and 2 for cosine and cotangent, 1 and 4 for sine and tangent. And the one thing I asked you to do is, since we're looking in this range, basically this range is from negative pi over 2 to pi over 2. What I asked y'all to do was go through here, and instead of making this 11 pi over 6, it's negative pi over 6 backwards. Instead of 7 pi over 4, it's negative pi over 4 backwards. Instead of 5 pi over 3, it's negative pi over 3. Instead of 3 pi over 2, it's negative pi over 2. And that's how we're going to read it backwards. So what we did on day one was we looked at questions like this. We said we want to find the arc sine of -1/2. So I know that sine is the y part of the point, and I know I'm going to look in quadrants 1 and 4 for sine. So what I'm going to do is I'm going to go in quadrants 1 and 4, and I'm going to find where the y is 1/2. So if we notice here, it's all positive. I come down here, it's -1/2. The value where the arc sine is -1/2 is negative pi over 6. So the answer to this is y equals negative pi over 6. I'm going to do one of each just so we have an example. Arc cosine root 3 over 2. So our cosine tells me to look in quadrants 1 and 2. I'm going to look for root 3 over 2. In the x part, there it is right there. Root 3 over 2 in the x part, that is positive pi over 6. So I know the answer to that is y equals pi over 6. Tangent -1, just so you know, it literally means the same thing as arctangent of 1. And what I did is I gave everybody this unit circle because it actually has the tangents on the outside. So I'm going to look, where does tangent equal 1? Well, with tangent, I look in quadrants 1 and 4. As I draw my finger along, I notice I have an undefined, I have root 3, tangent's 1 right there. Tangent equals 1, a little small, but I can see it. Trace my finger back. It's pi over 4. So y equals pi over 4 radians is where the measure would be 1. So that's how we are going to do the sines, the cosines, and the tangents. I'm going to go and find you a cotangent. Just cotangent down here at the bottom. So right here, this is arc cotangent. So this is basically, again, the same thing as saying y equals arc cotangent of -1. Cotangent tells me to look in 1 and 2. And what I'm looking for is where the cot is -1. So I draw my finger around and I see that the CO2, the cotangent, is -1 at 3 pi over 4. So this is going to be y equals 3 pi over 4. And the next one I want to do is actually want to do 17 because I want to show you that there is something that happens occasionally. Y equals arc sine -1 over root 2. As we look around the circle, there is no -1 over root 2. What I want to let you know is that -1 over root 2 is the equivalent form of this, -√2 over 2. So this is the same thing as saying y equals arc sine -√2 over 2. So we're going to go and find where sine is -√2 over 2. That's right here at -pi over 4. That's where we have that. This is going to be where y equals -pi over 4. The last two are your arc secant and your arc cosecant. So I want to show you these two because these two, again, if you look on the circle I gave you, secant and cosecant don't appear anywhere. So here's the deal. What I want to do is I want to put secant and cosecant in terms of sine and cosine. So if you think about it, y equals cosecant is the reciprocal of y equals sine. It's the reciprocal function. So what I'm going to do is I'm going to take the reciprocal of -2. And if you think about it, it's -2 over 1. So I'm going to take the reciprocal. So I'm going to look for the arc sine of -1/2. It's pretty much the same question that we have up here. So y equals -pi over 6. So what you always want to do is you want to turn it into the into sine or cosine. So arc secant is the reciprocal of arc cosine. So if I'm going to take the reciprocal function here, I take the reciprocal function here, and I'm taking arc cosine √3 over 2. Basically the same one as up here, arc cosine of √3 over 2. So y equals pi over 6. So in this case, y equals pi over 6. So that's the first thing we did. What we did is the following. We decided that we were going to learn how to take the inverse functions and not use the calculator. That's how we do it. In class, we practice this first side, answer keys up there. Practice it again. I can give you another worksheet if you need it, but that's kind of the general idea of that first day's lesson.